Okay, let us discuss problem number 2.12. So this is the easy program. So we have problem number 2.12, and this problem is related to finding pressure minimum. So finding P minimum. So let me read the question for you. So this says find the minimum attainable pressure of an ideal gas in the process. So the equation of process is given, T is equals to T naught plus alpha V square. So an ideal gas follow this equation. So gas is basically ideal in nature, and this follow this equation where T naught and alpha are positive constants. So you see T naught and alpha are positive constant. So these are the positive constant that is given to you. So T naught and alpha are positive constant. Are you getting? It is also given the volume of gas is 1 mole. So it is given V is the volume of gas. Even if I does not write, this means volume, and mole is given to you, so N is 1 mole. So you have to write equation for 1 mole of gases. So I need to find what is the maximum attainable pressure. So if the gases goes through this process, what is the minimum attainable pressure. So you have to find what is the minimum attainable pressure. How will you proceed? Minimum attainable pressure. Now the question is, how will you proceed? You see, the gases are ideal. What I want is, this equation is given in terms of T and V. I want to express this expression in terms of pressure, because I need minimum pressure. So I have to convert this equation in terms of pressure. So if I use ideal gas law, that is PV is equals to nRT. From there I can write volume is equals to nRT by P. Are you getting? So let us plug the value of volume here. So we will have T is equals to T naught plus alpha, V is nothing but nRT by P. This is a whole square. Now this is the equation in terms of temperature and pressure. So this contains variable temperature and pressure. Now what we will do is, so you see the process is a function of temperature and pressure. From here I can find P, and then I can differentiate pressure dP by dt and equate it to 0. Then I can get the minimum attainable pressure. This is one way. I can once, if somebody wants, you can also express this temperature in terms of pressure. So let us say, if equation is PV is equals to nRT, so let us call this as a equation 1. From here, if you want to eliminate T, so you will have T is equals to PV by nR. Are you getting? Now if you equate this, put the T is equals to PV by nR. This is equals to T naught plus alpha V square. And now this equation is in terms of P and V, because temperature is constant. So this equation is in terms of P in V. It is given the number of mole is 1, so I can write PV is equals to R T naught plus alpha V square. Now this is another form of the same thing. Now we have two possibilities. Either I can differentiate this equation. So if I want to differentiate this equation, then in that case I have to find dP by dV is equals to 0, because from here I can write pressure. So what is the expression for pressure? Pressure is R T naught by V, because if I divide by V plus alpha into V. So this is the expression for pressure. Are you getting? In terms of volume. So here you have a pressure as a function of volume. If you want, using this equation also, the equation number 1 here you can find pressure as a function of temperature. You have two methods, and then in that case you have to differentiate dP by dt is equals to 0, and from there also you can get the required condition, same condition you will get. Now let us say if I use this one, for me this is the easy one. So if I differentiate this, so this is a pressure, so now we have expression for pressure is R T naught by V plus alpha V. If I differentiate this one, so dP by dV, this is equals to R, and differentiation of 1 by V is minus 1 by V naught square, and the differentiation of V is alpha. This is equals to 0, so dP by dV is minimum, for pressure to be minimum dP by dV has to be 0. So from here I will get V is equals to, are you getting or not? So you will have, let me write alpha V square is equals to T naught. So V is nothing but under root T naught by alpha. So this is the required condition you will have. Now if you want to find the total pressure, you put the value of here. So pressure minimum, that will be R, and this is T naught by V plus alpha V, so I can write T naught plus alpha V square divided by V divided by V. Are you getting? So this is R T naught, and alpha V square is nothing but T naught, so you will have 2 T naught on the top divided by, what is the value of V? V is under root T naught by alpha. Are you getting? So if you solve this one, so you will have 2 T naught, so T naught goes, so you will have on the top 2 and under root T naught and into alpha. Let us say R will be also there, and you will have under root alpha into T naught. You can verify yourself, check yourself. So this is the minimum pressure that can be attained during this process. So this is the minimum pressure attained during the process of equation. You can get the same result if you differentiate this equation. That is, from here you find pressure first, that will be P square, you will have P square, that is T minus T naught. So you just find out the pressure from this equation and differentiate that, you will get the same result. Let us take 5-minute time. Even after ending this video, just make a stop and then take 5-minute time to try to get the same result using the first condition, that is this condition. If we differentiate here, that is the dP by dt is equals to 0, let us try to get the same result. You are getting or not? This is to get. We'll discuss the next problem.